All right. Hello, everybody, and welcome. Hope everybody is doing well. We are live, and we are going to pick up where we left off last week. And before we get into all the updates that I have, and there are many, I do just want to take a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Alazaran. That is the highest tier of subscription over on YouTube and Patreon. I would also like to thank all the other partners listed here. That is the next tier over on YouTube memberships and Patreon. They are for Khan Tokan, Gerboldes Inc., and Matt Osgard. In addition, I would like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, and Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me offset the cost of hosting this, things like the website, software licensing fees, things like that. I don't have any sponsors aside from you guys, so I greatly appreciate it. All that being said, this project and of course this channel would not exist without you guys. So I appreciate each and every one of you viewers, whether you're joining us on the Twitch side or the YouTube side. We do simulcast to both. Thank you all very much for being here. I greatly appreciate you guys as well. All right, so Adam over there on the YouTube side, how's it going? Good to see you. Welcome. All right, so we will kind of pick up where we left off last time, but what we're looking at this time is I actually made a bunch of updates between that stream and this stream, and we're actually at the point where the whole engine is actually compiling. So I've fixed all the compilation errors offline, and we're finally starting to sort of stitch back together this whole refactoring effort that we've been making for so long. So now we're kind of in the process of going through and resolving all the bugs and resolving all the errors that you see here in the console. We'll get to those things one at a time, but we're sort of stepping our way through that, and that's kind of the goal for tonight, is to see how far we can get with that, hopefully get things up and running. I know there's a number of resources that are going to have to be reformatted and whatnot as well. So that is the plan for tonight. Let me see. Aswin over there, good to see you on the YouTube side. Learning game engine development, I guess that I can be able to match 2D with commercial engines. I'm not sure 100% what you mean there, but first off, welcome to the game engine development community. We need much more of you guys, so it's always great to have new folks aboard. But yes, we, if you're talking about like what we're working on here, this isn't exactly what I would compare with a commercial engine, only because commercial engines are designed to support like a huge, wide array of things, right? And I'm one guy making this, right? So we're keeping it kind of small to begin with, and we're going to build on things as we actually as we need them. We're not going to add features we don't need until we actually need them. So if that's what your question was, there's the answer. You use this thing here that I have on the screen as a debugger. Yes, I do use that as my debugger, but I do not code in it. I code in NeoVim. Let's see. So let's see, it's compiler and debugger agnostic. So yes, I write my logic in NeoVim, but I do use this as my debugger. I don't like coding in this. It's just not what I prefer, right? But there isn't, as far as a cross-platform debugger, I haven't found a better one yet that works on Windows, Linux, and Mac OS across the board. So this is the one I use for now. It's the one I'm kind of stuck with, right? I think he means he's trying to build a better or adequate 2D engine because it's simpler. Probably a good choice on his part. Yes, I would agree with that. If you're learning how to build a game engine for the first time, definitely start with 2D. Don't start with 3D. And I would also say start with OpenGL, not Vulkan, typically. What is it, GCC? I assume you mean the debugger that we're using under here, or, well, I guess that would be GDB, right? We are using Clang as our compiler, which is pretty close to GCC in terms of what it actually, the way that it actually works. Obviously, the code it generates is much different, but we are using Clang just because that's nice and easy to set up across platform. So we're on Arch Linux here, but I have videos in the series telling you how to set that up on Windows and Mac OS as well. Let's see. Start with Ehrlicht Game Engine if you want 3D. Disable anything that's broken and try to rewrite it. That's fair enough. Yeah, so we are writing a 3D game engine here. But I've written a number of game engines over the years, and so 3D does not scare me. And so that is what we are writing on stream here. But I would say if you're writing an engine for the first time, 2D is the way to go. I would agree with that. All right. Internal static void. Good to see you over on the Twitch side. How are you doing? Why do you use the debugger that shall not be named instead of GDB? I find this one a little bit more intuitive to use, just because I can sort of hover over things and get the value of those things without having to do too much typing in the console. I did try a few plugins for NeoVim that sort of tried to emulate the way that this works, but I just really didn't like the way that it worked overall. And so this is the one that I kind of stick with for now because it's consistent, mostly consistent across platform. So yeah, that would be my answer there. Yeah, sometimes it takes me a minute to sort of catch up on both sides. So yeah, I do read both sides of comments, but sometimes when there's a lot of chatter from both sides, I have to kind of do one and then do the other. All right. Had to suck it up and learn GDB at work, and now all other debuggers are ruined for me. So at some point, yeah, I mean, I will fully admit somewhat that's a skill issue, right? I've never actually sat down and tried to debug something in depth with GDB that's any larger than a trivial project. So somewhat there's a skill issue there, and I just haven't tried it. I suspect, much like with NeoVim, right? Once I actually sit down and learn GDB, I suspect it's probably going to be the same for me. Let's see. Have you tried GF2? It's a front end for GDB. I have, and it's decent, but it's not cross-platform compatible, right? So I'm looking for something that is Windows, Linux, and Mac OS, right? And as far as I know, at least when I tried GF2 maybe a year ago or so, it was not the case. All right, so let's see. Also doing my little engine in C for physics and UI. I'm using Jolt and RMLUI. I'm not familiar with that one. I know Jolt though. These are C++ libraries. I built little bridge libraries so I can interface them with C. Yeah, so Jolt is actually something I'm strongly looking at for physics in this eventually. That's probably one of the few places I am going to use a library, but I haven't gotten there yet. Like the Jolt C implementations that are out there aren't really complete, so we might have to tackle that at some point. Let's see. Is it possible to make GTA games without a commercial engine? No, I would say. At least not on the surface, I'll say. So I'll also say this. GTA is built on a very bespoke engine, right? Rockstar has their own open world engine that's designed for open world scenes, right? It really highly depends on the type of game that you're making. So all their games typically tend to be super open world, like Red Dead Redemption and things like that. So their engines are built and tuned for that type of environment. And so, yeah, it's a bit of a manpower issue um, in terms of supporting something quite as in depth as GTA. But if you were to want to make a like a sandbox game on your own, it's doable on your own, but it would take you a very long time, right? Um, and so yeah, it tends to be like a bespoke engine that's worked on by dozens of people, and they have hundreds of artists working on their assets for it. And so that's I would classify something, especially modern GTA games. They're right up there. I would say in terms of complexity, right up there with MMOs. Um, they're highly highly complex things. We're not writing our own physics engine, so we are going to write a basic physics engine that handles basic stuff, right? But we're not going to write a full blown physics engine from scratch now. And the reason for that is because that alone could take years, right? So we're not going to write something that competes with like Bullet or PhysX or something like that. Ever played Ark? That game doesn't fit Unreal Engine. Yeah, I've played Ark. It's actually a really good game, but yeah, it starts to once you build a lot of stuff in your Ark, right? It tends to bog down quite a bit because I think they use blueprints pretty heavily, if I recall correctly, and that's just not fast. So yeah, all you would do is reinvent the wheel, anyways. So that expression I actually disagree with, right? So there is something to be said about. There's a lot of people that say, oh, don't reinvent the wheel, right? But it depends on what you're making, right? So a lot of times when you're making a game with very specific requirements, out of the box engines don't necessarily cut it. Like you would never want to use Unreal to make a Grand Theft Auto type game, for example. It's just not cut out for that. It's not meant to do that. You can do it, right? But it's not ideal. I wouldn't use it also to make an MMO. Doesn't mean you can't, but it means it's going to be a lot harder, right? Unreal is generally geared more towards first/third person type of games, right? So, I always say, not wanting to jump into something like this because you're afraid of, oh, I'm just reinventing the wheel is not necessarily always the right thing. Oh, not always necessarily the right mind frame. I'm 43, no time in life to write physics engine. I kind of agree with you there. I'm going to be 40 this next year. What's on our agenda tonight? So, how's it going, Mean Mr. Mustard? It's good to see you, by the way. So we are in a position where the engine compiles, and we are going through and resolving issues that are basically coming up in the console. It looks to be mostly issues with asset and resource loading, like no surprise. And we've got some issues with shaders that we've got to kind of step through. I've done a lot of work off camera as well. And so, yeah, that's kind of the agenda for tonight. I'm just trying to keep up with chat at the moment. Okay, let me check the Twitch side. YouTube is very active tonight, which is weird because it's normally not. Let's see. If you're compiling with debug symbols, it's actually super easy. We are compiling with debug symbols. Yep. Do you have some experience with procedural animation? A little bit. We're actually going to be diving into that at some point. Because we don't actually want to, for the first game that we're going to make, we don't actually want to use canned animations. We want to basically just have a few keyframes and make that stuff up on the fly. That's not 100% procedural, right? But it's not also the typical way that animations are handled. But we'll cross that bridge at some point. Let's see. MinGW has GDB for Windows. There's also WN debug that has a similar but inferior experience to GDB. That's fair. Fair enough. First time chatter, Lazy Man, welcome, by the way. What is your goal today? So we are in the process of closing the loop on a massive refactor that we've done. in changing the way that assets and resources are handled across the system. We added a packaging system. We added basically a drop-in replacement for the old way that resources were handled, which was structured around the original tutorial format that the series started in way back when. So we're also resolving a lot of tech debt. And so we've been actually refactoring for quite a while, trying to make things a little bit easier to use and a little bit more consistent across the board. And we're just now to the point where actually the engine builds again. And so we're kind of just working our way through bugs. And that's kind of the goal today, is to kind of knock some of those out. Dr. Elliott, it's good to see you. Welcome. Let's see. Writing my master's thesis on the comparison between procedural animation and motion capture. And I'm looking for perspective, hence the question. So I haven't done a lot with motion capture directly. So I'm probably not the person to ask about that. It interests me, but as a team of one, I don't really have the access to that. And I haven't really developed anything that requires mocap. So that's super interesting, though. That kind of stuff does interest me, but I just haven't had a lot of experience with it. So I don't know that I'm qualified to answer that question. All right. Let's see. I'm new to this channel. I have, I have a intermediate knowledge of C++ and basic knowledge of OpenGL. No experience with Vulkan. Will I be able to follow? If not, where should I learn Vulkan? So, I do start. So this series starts off as a tutorial series, where we kind of go through everything from a low level. But I think it's quite a while before we actually start touching Vulkan directly. And I think it's actually, like, I want to say 21 episodes in before we actually clear the screen, which is like the first big major update. But the reason for that is because we're building an entire engine, not just a renderer. So we're setting up the groundwork for a lot of other systems and things that we're going to need later on in the future that we're now actively using. And so we do go over a lot of concepts, Vulkan concepts that kind of translate outside of just Vulkan, but this tutorial series in the beginning is Vulkan specific. So we do touch on a lot of different things with that. And I think if you have some basic knowledge of OpenGL, this will probably make a lot of sense to you. If not, I do try to explain things on a high level. There are certain things that I have to kind of skip over. And so I would say a combination of this series and also reading and understanding the Vulkan spec in general, and then using websites like VK Guide also to help round out some of those things would be good. Let's see. Started with C++ 14 to 15 years ago. This year I relearned C++ 20 and built my own engine. Nice. That's awesome. Run Snake, Sansom, and Cellular Automata. Currently in 8 months. That's awesome. That's really cool. I love hearing about stuff like that. If you're not creating tutorials and streams the entire way, it won't take you 6 years like it does me. Yes, that's true. I'm 3.5 years into it. Yeah, but that's mostly because of explanations and answering questions and stuff like that. Yeah, if I were to estimate the in total time of work, amount of effort / time spent in here, it's realistically, we're probably up to about 9-10 months of work. If I were doing this full time at this point. But yeah. Series is great, by the way. Love it. Awesome. I'm super glad to hear that. Thank you very much for the feedback. I appreciate that. It always is good to hear that it is useful. All right. So I should probably get in and actually start doing some things. So, like I said, we are going to kind of step through and do a little bit of troubleshooting and try and resolve as many errors as we can. Maybe we'll get to all of them. I don't know. But we'll see. All right. So we have a shader compilation error here. And so one thing I should point out, as far as like where we are with all of this, let me bring this up. So this is obviously everything that's output by our logging system. So where I've gotten is the engine actually starts up, it runs, we load our plugins successfully. All of our plugins load up correctly. We have our Vulkan renderer that gets stood up correctly. All of our resources created, all of that stuff is initialized. All of that is good. So this is just all the logging having to do with that. And then a little bit further down, let's see, we have some more Vulkan stuff regarding, window creation, swap chain, surfaces, all that good stuff. Our job system is set up, so that works just fine. And then we also have texture creation up and running. That looks like it's pretty much good to go. So texture resources are working at the moment. And then we also have some shaders loading, right? So some of our shaders, I think, are not configured correctly because we changed sort of the file format having to do with that. But we can see here that we are actually loading assets from our packages, which is a huge thing. It's something that we've been working toward for quite a while. We also see that our hot reload watches, or at least are being logged about, right? We don't know if they work yet, but at least they are being set up. And so whenever we load a shader, we also then load the vertex and fragment or whatever other stage, sort of sub assets are required for that. And then here we are compiling the vertex shader for the material standard shader. And it looks like at this point we have an error compiling that, and then it looks like we've got just a bunch of fallout from that. And then also it looks like we've got maybe some case and parsing errors because we've made some small updates to that language. So for those of you who are new here, Kson is sort of our proprietary, if you will, storage language, right? So it's like a storage format. So it looks very similar to JSON. There's a few syntactic differences between that and this. But we did that as a learning exercise into how to actually make a language from the start, writing the lexer and parser for that from scratch, and getting that to work. So it's not like a full Turing complete language or anything like that. It's really just a storage format at this point, but at some point, maybe we'll expand that. So it looks like we have some things, some fallout errors from all of this stuff. So it looks like our vertex shader looks like line 161. Error, nothing. Syntax error, unexpected identifier. So let's take a look at material standard vert and see what we can't figure out there. So material standard vert. And so we're going to want the one in kohi runtime shaders under assets. That's going to be this guy. And I believe that said 161. Now, interesting. We only have 160 lines in the file. So I wonder what it is on about there. Unexpected identifier. So what I like to do is I've actually rewritten these shader files to meet sort of the new way that we're doing things. So I should probably step through this as well. This is one of the things I did offline. So we had our directional light structure, our point light structure. Those haven't changed. We have our sort of what used to be called a bias structure. This is renamed to NDC to UVW. It's just a matrix that we use to convert from NDC space to UVW space. And then we have our vertex inputs. That hasn't changed for standard materials. And then we have our per frame uniform buffer object, our per group object, and then we have our per draw object. And mostly what's changed in here is the fields to match the new material system. So most of this stuff in the per frame, which means basically updated once per frame. Most of this stuff hasn't changed. The only thing we've added a couple properties, right? We have the delta time and game time being passed in now. So if we need something to animate, we can actually use that within the shader. And then I think all of this stuff is actually mostly the same. We've just sort of cleaned it up and refactored things a little bit and kind of organized that a little bit better. So we've got all of our inputs here, our vertex inputs, and then our uniform buffer objects. So we have our per group. So for materials, you can think of this as one per material, base material, if you will. So that'd be like your wood material or your metal material or what have you. And so we have things in here to specify lighting information, which a lot of this is going to be moved to a storage buffer when we have those. And then we have our lighting model, our flags, our texture usage flags, and then all of the various fields that we have here. So the base, color, emissive, normal, metallic, MRA, roughness, all that stuff, right? And then we've bit packed this stuff with padding to round these things out to 16-byte fields, right? So that all of our alignment doesn't get messed up. Thank you for the follow, by the way. Appreciate that. Welcome. And then finally, we have our per draw uniform buffer object, which instead of just taking model, now takes the clipping plane, which is also something, I think we already had that in place before. It takes a view index, which is used to index into this array right here and this array right here. And then we have the irradiance cube map index, which is new as well. And that is, we have irradiance maps. We have an array of those, so it's used to index into that. And then we also have a data transfer object to go from the vertex shader to the fragment shader. And then we've simplified a few things here. We had a whole bunch of stuff going in the DTO that really didn't need to go in the DTO because we have these available in all stages. So we went ahead and cleaned some of that up. And I think otherwise, most of this stuff is the same as what's been in here from before. The only other thing to mention is we do have this new unpack texture map channels. So we have 3 individual textures that use a specific channel to texture or to sample from. So our metallic texture, our roughness, and our ambient occlusion, those only need 1 channel worth of data. So we can actually specify in here what channel to pull from when we're not using a combined MRA texture to pull from those. And those are all packed into a single 32-bit integer. And so this unpack U32 is responsible for unpacking those values, X, Y, and Z, from N, which in this case, N is the texture channels. That's the 32-bit integer. And then we have the individual channels for metallic, roughness, and AO right there. So that is pretty much it. I think what I'm going to do is I like to actually, I'm going to use GLSLC, and I'm going to run this through there and see if I can get a little bit more error information from that. So let's go ahead and open up a terminal. And we will do GLSLC, and we're going to use, let me get this out of the way. So we're going to use GLSLC to compile a vertex shader stage shader. And that's going to be material standard vert GLSL. Now, this is not going to work because we haven't changed directory into runtime asset shaders, which is where these things actually live. So if we run this again, we do not get any errors, which is interesting. So this was complaining about unexpected identifier on line 161. So wait a minute. Let's see. Vert. So I'm wondering, unable to create shader module, and that's the vertex shader. I wonder if somehow those are getting transposed. Oh my God, you actually care about alignment? Where did you come from? Yes, alignment's super important when you're talking about shaders. So yes, definitely an important thing, and it's screwed me many times not having it right. What aspect of physics engine make you scared of for the time? I'm not sure if I understand the effort it takes, unless you mean cloth, fluids, that sort of stuff. So yes, those things for sure. Writing like a basic rigid body simulation, I don't think would be that crazy. Making it performant would probably take a bit of effort, right? But I think, it's just a matter of getting the math right, really. That's the biggest issue. Fluids aren't handled by regular physics engines. They're not used in games yet. Cloth and water are just physics-enabled planes usually provided. Yeah, I mean, it depends on the game, right? There's lots of different ways to do it, and it depends on what you want to do with the water, right? Some engines where you don't really interact with it as much, or like they'll do things like use particles to kind of fake it, right? It really depends on what you need to do with it, right? Is it going to be sort of a body of water that's stationary that just has stuff like floating on top of it, or is it like a waterfall, right? Those are very different things when it comes to fluid simulation. And there's some pretty advanced stuff out there for sure, but we're not going to be writing that from scratch here, mainly because I don't need it, right? Again, we're only going to write what we need. Okay, so let's see. So why would we get... Let's actually... I'm going to put a breakpoint. Let's see. That's probably going to be a %s shader module. There it is. So we're going to put a breakpoint here. We're going to run this. Okay, sure enough, we do get an error. So let's see, that's the resource name. You know what, let me put the breakpoint here, one line after, so we actually get this output. Okay, so the resource name for material standard shader will be destroyed. Right. Okay. So I guess that looks like the vertex is usually the first stage in line. So let's actually rerun this and step into that code. And actually see if we can figure out what... Let's see. Okay, so we're setting up our shader, stage information, vertex for shader material standard. Okay. So that's the K name for that. And let's see, let's take a look at the source. Let's just make sure that, let's see, we have version 450. I don't think this is going to give us anything. Yeah, it's not going to give us anything that's useful. Let's take a look at source. Okay, so I mean, that looks like it's probably right. All right, shader kind is vertex shader. So, okay, so that's being passed to shader C correctly. Shader name is, or the file name is material standard vert. What is the compilation result? Okay, so we do have a result. So we'll get the status. compilation error, right? And so unfortunately, it doesn't look like it gives us much of an error message outside of what it kind of told us in the console. So let's see. I hate this sometimes. Unexpected identifier. Now it's saying line 160, which I'm wondering if that's off by 1. But what's really interesting to me is that when we run this same exact file through GLSLC, which essentially is the same thing, this works fine. Let me use another option. I'm going to output to minus, which basically means output to the standard stream. So I mean, output GLSL 450. So this is essentially this is the spur V output from that. So the fact that it output this is actually it's meaningful in that it was successful. So it's a bit interesting that it loads from here, but it doesn't load when we do it this way. I wonder why that is. This is something that we had working previously, but because of the way that we are loading, I wonder if maybe this isn't zero terminated correctly or something stupid, right? I wonder if I can do this in the debug console. 4932 is what it's saying for that. So material standard. Whoops, I need the vert. Right, selected is 4926. According to that, 4932. So what is the discrepancy here? I wonder what the discrepancy is between. Oops. Yeah, because there's a difference in bytes here between the two. And it's not enough of a difference to say, hey, that's probably just... I mean, it's not even carriage return new line, right? Because this isn't Windows we're on, so we don't even have to worry about that. Let's see. Always echo inputs when debugging. Yeah, for sure. Maybe you pass arguments incorrectly. It's possible. But the weird thing is I haven't actually modified that code. So I'm thinking like however it reads from the file is probably what's different. It's good for, this is good for moving quickly to the bugs that were found for people who aren't PowerVI or Emacs users. Yeah, that's fair. Thought this was a safe stream. Yeah. I mean, we don't say, the name of this, right? Because it is a family friendly stream. I do have to have it on the screen, but whenever we say it, we bleep it like that, so we say VS, it's a family friendly stream. So I don't say it, I don't just throw that term out there lightly. Default OpenGL something versus expectation. That's what I'm wondering, right? So I'm wondering if maybe maybe in here somewhere it's like defaulting to let's see, like maybe target environment is like defaulted different between the two. It's the only thing I can think of. But again, like this was working before. Oh, I need to turn my allocator back on, actually. So let's see. Do we have... So this is the compile into SPV, SPRV. Entry point name, do we have? Yeah, we use main, okay. Additional options. We don't have additional options. We don't have compile options, right? We're not using that. So maybe we should use that. Takes a pointer to those for some reason. Okay, so shader C compile options. Let's see what's in that. Oh my. Okay. What is initialize? I wonder if I should just use this structure here, right? Thank you for the follow. Welcome. Let's see what this has in it. Oh, is this just a opaque struct? Don't tell me it is. Yes, it is. Dang it. Okay. So we can't do that. Let's see. Clone, release, set limit, initialize. Let's see. So this returns. This returns an option, shader C options T, compile options T, options equals, right? So we could just do the address of options here, I think. What is this bleating about? What are you bleating about? Shader C compile options T. Did it not want a pointer to that? I thought it did. Nope, it didn't. Okay, I misunderstood that then. Right? Shader C compile options set limit. Sets a resource limit. Let's see. We got a whole bunch of stuff in here. Should invert Y position. Min and max built-ins. Okay, we don't need that. Sets the target shader environment. That is probably what we need. So, 0 maps to Vulkan 1.0 if target is Vulkan and it maps to, okay. So what do we use? We need options here. And then target is going to be Vulkan. And then version, do we just need to type like, what does this want? Like 1.3? For version value should be Oh, shader C environment version. Okay. Here we go. That's what I'm looking for. So Vulkan 1.3, which winds up being that for some reason. Okay, that's fine. All right, so I guess let's try that, right? Maybe that will get us somewhere. Let's restart. Probably need to put a breakpoint here, actually, where it's doing this. Error compiling shader with 1 errors. Let's put a breakpoint here. So it doesn't look like that has actually solved it, right? I figured by specifying the version that maybe it would resolve that. The problem is it's like shader C is actually not giving me a meaningful error, which is super annoying. Who goes to a game engine stream looking for safe? Yeah, fair. C and C++ are about speed. Safety's your own problem. Ain't that the truth, right? If you want to be world's best programmer, take this one single piece of advice. Learn how to make a single code file fast, efficiently, and correctly. Do that many, many times and you'll have all codes. Yeah, more or less. It's pretty good advice, right? Repetition is really the key there for sure. Don't talk Rockstar up too much. Their game runs a 6-year-old scripting make with a dog shit Lua and doesn't even optimize the loading with multi-threading. Truth is, Erlich could do better. So, the difference between Rockstar and like indies, right, is they have a lot of people to throw it at, which I never agree that throwing more people at the problem is a solution, right? That's almost never the answer. But sometimes it can like plow you through the problem, right? Even if it's not correct. Sometimes it'll get you there faster. Like there's no arguing that, a team of 300 people can definitely, accomplish something the size of Grand Theft Auto that a single person cannot, right? I would say probably even a small team of like 5 people couldn't make something the scale of Grand Theft Auto. So it's not necessarily talking them up. It's more talking about the difference between a large team like that and the amount of work you can handle versus a smaller team. That being said, yes, there's lots of overhead with having a team that large too. So it's not all like candy and cake, for sure. What do you think about Zig as an alternative for C? Every time I try an alternative for C, I always go back to C. And I have a great many number of friends of mine who have tried it. If you want, actually, I'll give a shout out to somebody who has tried this, who is Spiridon FL, right? So Spiro has tried Odin, he tried Zig before that, and he still keeps going back to C. Just because a lot of those things wind up, you eventually find something and it's like, you know what, I should just be doing this and see. So yeah, shout out to Spiro there. He's a Giga Chad developer here on Twitch, and he is actually making some pretty cool out of the box stuff. So he is actually rewriting his engine that he wrote initially in Zig, ported to Odin, and now is rewriting in C. Where he basically has a game that is powered by Twitch chat that makes use of WASM as well as the HTML DOM as his renderer, because people told him he couldn't do it, and so he wanted to set out to prove them wrong, and so that's what he's doing. But yes, it always winds up, all roads lead back to C. What about Jai when it comes out? Do you think it will be a C, C++ replacement? I do not. I think Jai is excellent from what I've seen. I haven't actually tried it myself, but from what I understand, it's pretty excellent to work with. I know another streamer here has been using it to make his game called Fat Goblins, and he coded the whole thing in Jai. In fact, I think he might even be the first one to actually who's going to release a game in Jai. But, you know, there's a bit of a single point of failure there because it's not open source, at least at the moment. I don't know if Jonathan Blow has plans for releasing it open source, but unless it's open source and other people can pick it up and run with it, if he decides to just walk away from it one day, then you're stuck, right? And so that is what's keeping me from going that way. All right. So that didn't get us anywhere. I'm beginning to wonder if like maybe we have, let me try one more thing because I know that sometimes vert. I want to take a look at, let me first off, I know that sometimes not having like a trailing new line can be an issue. So let's try that. I don't think that's the issue, but I'm going to try it anyways. Okay, yeah, it looks like it's still. Okay. Still unexpected identifier. So now I'm kind of wondering if it is indeed something like maybe the string isn't terminated correctly, right? Because if we take a look at in fact, let me go into let me take this, right, and just put it here. And we'll do source length. And we'll do that, right? And then source length. Actually, there is one more thing it could be. There is one more thing that it could be, but before I check on that, I just want to verify. $49.33 is what it says the source length is for the vertex shader. Okay, so the source itself, if we take a look at that file, which is here, 49.27. What is that 5-byte difference, and why is this so much longer? Okay, so what I'm going to do, actually, is I'm wondering if my string length function is like busted or something stupid. Because one of the things I did do offline was I was trying to remove some of the standard library functions, and this was one of them. So we have string end length. So all this should do is loop through until it finds null and then break. In fact, it should probably, I mean, I guess, yeah, we do a sanity check here and then that, right? So I guess one thing we could try, let me actually, before we even debug this, let me go to, we actually have a flag here that I added, right? So I'm actually going to do this, and then string length, we have a string n length, which is here, right? So what I'm going to do is, right here, if we are using this, then we're just going to do return string length, string, right? And I want to see if this is actually different, right? So what we'll do is else, it shouldn't be, but maybe it is. Maybe I fat fingered something there and I'm just not seeing the issue. All right, so source length 4933. Okay, so my function is fine. And we still get the error. Okay, so it's not that. I guess the other thing I could try is, let's put a watch on source, right? And we're going to say that it's an array of, what did I say it was, 4933, I think. All right, so let's go with 4934 in order to get the null byte. So I'm going to actually take a look at all the data. And actually, oh, it clamps it off at 1,000. Okay, I guess that's fine. All right, so I guess we'll try to watch those things specifically. So we'll say source, and we're gonna say index 4933. Right, so that is null. What is the next one behind that? Rubbish. Right. Let's look at 29, or maybe 28, right? Because I think that's what the file said it had in it. And so let's see. Let's take a look at this. So the last character in the file looks like we have should just be a new line, right? So it should be. Where is all this stuff coming from? All right, let's skip back a few more characters. So we have F, and then we have another F, right? So that makes sense. And then we have the semicolon, so that's probably this. Then we have a new line, right? Then we have this guy, and then we should have another new line, right? And then that essentially should be the end of the file. So this 4926 should be, well, I guess it's another new line. Let me see. Yes, I guess we do have two new lines there. Okay, so it should be 4927. And instead we have this, right? So I think that's the problem. Whatever we're doing when we're reading this file is wrong. So it's essentially reading more than what the actual file has in its in its actual data, right? Because we only have 4,927 characters, which means that 4926 should be index 4926 should be, or I guess it would be index 4927 should be a null terminator, right? And we don't null terminate until 33, I think it was. Or was it? Whoops, 44. What was that? 40. Wow, I got that completely wrong. 49:33. There we go. Right? So for some reason, we are completely just blowing that out. Okay, so I think this has to actually do with the way we're reading in the asset. So let's take a look at. I guess it might be a VFS issue. So when we request an asset, we have kpackage asset text get or bytes get, right? And text get gives us a string, right? And also gives us a size. And then binary also does that same thing, right? So I'm wondering if maybe we're doing something stupid where we're requesting this as binary, or somehow we're reading too much data out of this. Let me take a look at this function and just make sure. Let's see. Get asset data, right? Is binary is that second flag that is set to false. Okay. So if we do that, is binary, right? So let's see, that's the package is binary. We want the file system open is binary. So file system open takes binary as a Boolean. Let's go into that real quick. I don't think the problem is this far down. So binary. Okay, so let's see the mode string. If we are read and write, then this is essentially the string that we pass into fopen. We are only going to be read, right? So if we're binary, we use RB, otherwise we use R, right? So that's going to be false, so we're going to use R, which is going to be the correct argument to pass to fopen for the mode string, right? So if we go to man fopen, we can see here, I think this is the entire thing, right? Restrict mode. If we check out the, actually, I may need to actually do this. Quit. All right, let me do this over here. All right, so yeah, right there. Open text for reading. Stream is positioned at the beginning of the file. So this is the correct argument. Okay, so I'm not worried about that. So the problem isn't here. I'm pretty confident in that. So we have file system open. I guess what we should probably do, asset get data. We do a file system size here, right? And then we do file system read all bytes. And then we get the read size, which is basically how many bytes we read. So we have a file size and read size. Those might not line up. If read size is less than file size. Okay, so I don't think we got any read size mismatch, right? I suppose we could probably change this to, right, if those are not, if those are not equal, right, we could probably reasonably say that we should bleat about that. Let me see if that actually does it or not. Okay. Yeah, so I don't see any trace messages in here about a mismatch. The only time I've seen a mismatch is on Windows, where the file itself, like the text file, actually contains both carriage return and line feed, versus on Unix-based systems where it's only line feed. So I don't think that that is the issue. Asset get data. I wonder if we should do read all bytes, read all text. Don't we have read entire text file? I thought we had this. So when I wrote this initially, we didn't have something to read the entire text file, right? So this read entire text file maybe is the way that we should go, right? Because we also have file system read entire binary file. So instead of doing an exist check, an open check, file system size, all that stuff, that is actually done for us by our file system. So I'm thinking without the need to even have a file handle, right? I think that just maybe is the way that we should go. So the only difference is we can't quite get a granular error message, although I guess we don't really have that much of an issue here, right? So when we do read all text, what does this do? Let's see, file system size. So we read into out text. So out text must have been pre-allocated. So data is the out text, right? So we do file size. I wonder if we should do read size. Or no, it has to be file size. We don't have read size yet. And kallocate actually zeroes out the memory for us automatically as it is. So that shouldn't even be a problem. I guess what we could do is we could step through this, right? So k package c 181. Thank you for the follow, by the way. Check the file length during let's see. Check the file if the file length during reading is 4927 or 4923. So I don't know if the file system is fault. Yeah, exactly. So that's kind of what I was getting to. Let's do. You know what? Let me clobber. Actually, wait a minute. All right, we don't need that one. I'm going to get rid of some breakpoints here. Actually, I think I can get rid of all of these. Okay, so I'm going to put a breakpoint here, right? So I can get the file size. And then what I'm going to do is I'm going to go to, let me stop this. Then I'm going to go to, let's see. I'm going to go to, let's see, asset system. How do I want to, I guess I need to, shader serializer. Probably ought to go to the shader resource handler. right? And when we load the text resource, this is probably where we're going to want to be. So I think we go through each of the stages here. And so when we kick this off, we request a text resource, which requests a text asset, which reaches out to the asset system, down to the VFS, down to the file system. So let's go ahead and do that. All right. So we're going to go ahead and, let's see, we're going to go ahead and do that. Actually, I'm kind of surprised that we didn't hit this other breakpoint yet. I'm just going to kind of continue and see what happens. So we're loading this here. All right, so file size is 4927. Right, so we're going to go ahead and read. We're going to read all text. And then the read size is 4927. Okay, so if we do data here. Oops, let's see, data 4933. This is going to wind up being, what did I say this was? 4927. I guess it would be 26, right? Why does that not... Oh, I think data is a void pointer, isn't it? Yeah, I think it is. Yes, it is. Okay. So it doesn't know what to do with that. All right, so we need to cast that to a character pointer. There we go. Okay. So 4927. That is bizarre. So it's told me that the file size is 4927 and that the size that it read was 4927. But if we look at the actual data itself, it goes well beyond that, right? Index 4933 is actually where that string ends. So when I do a string length on that, it's wrong. That's interesting. So we do a k-allocate file size. And we're essentially overflowing the buffer at this point, which is part of the problem. Which is going to cause other issues too. Oh, I think I know what the issue is. So file system read all bytes. Read size ultimately comes from fread, right? Which I think if we do I think I know what the problem is. So let's quit out of this one and we'll do fread. Okay, so reads X items of data, each byte size long. We're reading single bytes at a time. I think we're reading single bytes at a time, or do we read the whole thing? Let's see. So yeah, we read, yes, single bytes up to size into, okay, yeah, we're not null terminating the string. That's the entire problem. I think what's happening is the reason it's coming up as 4933 is because we just happen to have that null character in memory. But what the actual problem is our buffer actually isn't big enough to account for the null terminator, I think is what's happening. Does this say anything about the null terminator? I don't think so. Success, return the numbers of items read or written. If an error occurs or the end of the file is reached, the return value is a short item count or 0. Okay. So, to me, what's actually happening here, the issue here, is that, let's see, our out text, essentially, that's getting passed here isn't big enough. It needs to be one byte larger, and then that last byte needs to be null terminated. So, what we really want is when we k-allocate this, we want to do file size plus 1. And then whenever we do file system read all bytes, which I think is also an fread, it is. So either way, whether we do a read all bytes or read all text, we should probably, I suppose we could probably, we should probably add this to these functions instead of trying to do it like, or rely on the caller to do it, I feel like. Although user code's never really going to access this, so I could argue the opposite of that, right? Realistically, what we need to do is data, and then I guess it would be file size equals 0, right? And that's going to be any type of data that we deal with, right? So we could theoretically, we could just cast this to a U8 array, right? Because it doesn't really matter the underlying type. We're reading bytes. We're only dealing with bytes as far as we go, right? So null terminate the final byte, right? And actually, this is not 100% correct, right? We actually only want to do this if it's a string. Thinking about it now. So what we actually need to do is we don't want to do file size plus 1 for binary, right? Because we only want to actually include that for binary. So I could do this in line. We'll just say plus is binary. Oops, that is not what I wanted. Where did that go? What did I hit? There we go. All right, so what we actually want to do is we want to say is binary 1, 0, right? And I suppose we could just cast that as well, right? But this way, we will want to null terminate, and actually we could just say this is a character array. That I think is going to solve the problem, right? Because we only want to do this for text. We don't want to do that for binary file reads. Okay, so the other question is, yeah, see we have file size here. So I suppose what we could do, instead of doing it this way, we could do if is binary, right? We do file size plus plus, right? And that will just account for that. And that way, we don't have to worry about how that's handled down here. All right, let's go ahead and build that. Thank you guys for the follows, by the way. Appreciate that. Okay, so let's go ahead and run this. I'm actually just going to disable this breakpoint. Continue. And I'm going to disable this one too. All right, we got further. All right, And the reason I can say that is because we're getting Vulkan errors now. So that means that we actually loaded the shader. It's just doing really funky stuff. So it looks like we had a bunch of validation errors, and then it pooped on itself. So here we go. So we were able to compile the vertex and fragment shaders successfully. So it was not an issue with our shader file. It was not an issue with shader C. It was purely an issue with our file system not null terminating strings as it should have. So that is fixed. All right, so the next thing it looks like is about push constant ranges. Okay. So looks like the push constant range is not greater than 0. So we're probably going to have something to do with that's going to have to do with our per draw uniforms not being set up correctly. So we're going to have to figure out why that is. Let me go ahead and catch up on chat, because I know we have had quite a few comments before or as I was coding, right? All right. Can you inspect source directly in the debugger? Yes, but it's kind of tricky with really long strings. So it's a little bit easier to, unfortunately, to just do it this way. Because like if you have, let's see, is this still running? Let's see, what do I have? Out message. I don't have context on any of this stuff, but yeah, basically if you get a really long string in here, it'll print like 100 or so characters of it, and then it just truncates it and you can't actually view it, which is really annoying. Are you familiar with pre-make configuration system? I've used it before, enough to know that I don't want to use it for this project. Okay. First time chatter. Gebestercat, welcome by the way. Really want to build my own engine. Do you recommend a particular language graphics API? I want to use Go and OpenGL, but I'm not sure I want to call C code in Go. So I will say this. If you're wanting to get into game engine development, the way to go is going to be C or C++ usually. Those are not the only options, but they are the industry standard for a reason. You'll have the most selection of libraries to use with that, if that's the way that you want to go. There are lots of bindings out there for C and C++, but like I said, they are the industry standard. You know, I have seen people do things like, let me find it real quick. So this was actually something I was just talking to somebody about the other day, and I've brought this up on stream before. Let's see. This is it right here. So there's a, wait, is this the right one? I don't know that that's the right one. Yeah, this is what I'm looking for. So let me show this to you guys. So people have actually taken and used PHP to develop OpenGL, right? I've actually talked to this guy a little bit, and he said it started off as a joke, but then actually was like, hey, this could actually work. So, you know, you can use whatever you want, but the real question is, do you want to eventually get a job in that, doing it professionally, or are you looking to stay indie? If you're looking to stay indie and just kind of do your own thing, then use what you know, use what you're comfortable with. But if you're wanting to do it professionally, you are going to want to use something that is at least close to, if not exactly what the industry uses, which is typically C or C++. But let's see, recommend a particular language. So language would be C or C++, is what I would say. And then graphics API, I would say if you haven't done graphics programming before, do OpenGL until you get familiar with graphics concepts, and then switch to Vulkan. Didn't kallocate 0 the memory. I would make the read text function put a 0 at the end anyways. Yeah, so it does 0 the memory, but the problem is the whole buffer wasn't long enough to actually include the 0 at the end. That was the issue. Turn areas backwards. Oh, yeah, I think we did away with it anyways. Yeah, this is ultimately what I wanted to do. But yes. So is the if. Is binary. Oh, you're right. Wait a minute, though. Why did that fix it then, if that's the case? Oh, I know why it fixed it. We got lucky. Because our shader file actually had an extra new line at the end. So we were just like nuking that and putting a 0 instead. So actually, yes, you're correct. This is what it should be. It should be if not binary, then we increase the file size. And if not binary, then we go ahead and we do this, right? So that is, let me go ahead and rebuild and verify that. Here we go. So let's actually restart that. It's still going to throw all kinds of Vulkan errors, I'm sure, but okay. Oh, interesting. So it's actually pooping itself again. Okay, so what that tells me is it's possible, actually. Let me see. Actually, didn't we verify that it was? I thought we verified this. Right? It's not binary. So we want to increase the file size by 1. Oh, this is going to be wrong. Because what we wanted was the original file size. We want that. Right? Because we're increasing the file size by 1. But now we're actually still writing outside that array. So that technically wasn't accomplishing anything except clobbering memory. So let me disable that. Still pooping itself. Maybe that wasn't it. Why did that work, though, when it was binary? Weird. Backwards from what I expected, for sure. Noah Pop, first time chatter, welcome. Backseating programming is hard, yeah. Yeah, for sure. I think you're writing to unallocated memory now. Yeah, I think I was, which is why I did that. Right, because file size, if it's not binary, would have been increased here, so we have to cut it back by 1 to 0 that out, which, technically speaking, we probably don't even need to do, right? If we're creating our buffer 1 byte larger than we actually need, and this is zeroed out from the beginning, technically this last step shouldn't be needed. Let's see. I've been learning C++ and I think I'm competent, but by no means great at it. Fair enough. But want to contribute to Vulkan-based open source projects. Do you think a ton of experience or skill in C++ is required to be able to contribute? So Vulkan does rely pretty heavily on a good foundation of memory knowledge in terms of how it works, allocation, various memory operations, things like that. So you're going to want to have a pretty good command of C or C++ and a pretty good understanding of how all that stuff works. When it comes to allocating memory, alignment, things like that, before you jump into Vulkan, because if you don't understand those things, you're going to get lost quick. So I would say, if you're competent, give it a shot, but do be prepared to be looking things up quite a lot. So nice to be able to finally join the stream, but I have to wake up in 2 hours, so good luck starting the engine. I appreciate that, Lazy Man. Thank you very much for being here. Have a good one. Feel lucky to caught the stream of someone like you. I appreciate that, and welcome. Let me see. I've seen kids to learn to make bad games in 2 years. Yes, so it depends on. If you want to make a good game that's performant, it's going to take quite some time, right? Let's see. Catch up on the YouTube comments. Because of undefined behavior, it's not actually working, most likely. YouTube chat, yeah. No, I mean, I do try to keep up on it, right? But let's see. There's a question here. Yeah, C++ is great. Do you recommend any learning resources? So what was that site that I found? Give me a second just to find it really quickly. Here we go. I haven't used this in great depth, but I've heard great things about it. So there's learncpp.com, which basically gives you a whole bunch of modules with like learning things about C++, right? And it's fairly extensive, as you can see how long it took me to scroll that page. So this looks like a pretty good resource. Also, reading the C++ spec is also another way to do that. So yeah, I would maybe start there, but by and large, the most important thing I can tell you when learning any language, and I'll drop a link here in chat, when learning any language is to use it, because using it is how you are going to learn language the best way possible. Because if you sit there, you can read theory and you can read about the concepts all day long, but until you actually get your hands dirty and actually start writing code, you're not really going to pick up on much, right? All right. Isn't the first argument of the return value in case of true is binary? Did I? I'm still not 100% sure I have this right, but let me build. It seems like it should be right. Okay, why are we getting a... This generally happens when we have like an empty string being passed or something. Okay, failed to load shader resource first shader, and then we're using a name which looks like a K name to me. So we're probably just not... Yeah, it is a K name. So shader system gets, we need to fix that. We need to fix that, because what that is doing is that is essentially using kname directly in the error message, which is wrong. That should be kname string get name, which will give us the actual string that we actually want to write that message out. So there's that. This is the kind of stuff that we're going to have to fix because we've changed so much stuff in terms of, our refactor. So expect to run into stupid issues like that, right? Okay, so we have a copy memory, asset to resource. Okay, so we have custom samplers. All right, so yeah, we've got some other stupid stuff in here. We still haven't solved this issue, but we actually have like some fall through that's kind of exposing some other issues. So I'm actually going to fix these. So k-resource handler material. And that's 175. Okay, so one thing we didn't take into account here, whoopsie, is we just allocate a C array and then copy memory from custom samplers that might not exist, which I don't think we have any materials actually that have custom samplers. So we want if out material custom sampler count, and then we can do this if that is warranted. Otherwise, we should not. Custom samplers allow us to specify custom samplers for different texture maps within a material. So if we want a special kind of sampling to be done on a texture within a texture map, or within a material rather, that is the way that we do that. So let's go ahead and run this again. Okay. Looks like we have another one. Oh, interesting. So if we have sampler count 78, yeah, methinks that's wrong. Let me look at this out material in general. Okay, see, we've got rubbish values in here, so I don't know what this is trying to load, but it seems like we've clobbered memory somewhere, which is likely an issue from this stupid stuff up here. So let's go ahead and take a look back at this. File size, let's see, do we use file size anywhere else? Read size is, oh, we didn't assert on this. Read size is less than file size. I should probably step through that again just to see exactly what it is doing, because something is afoot. All right, so let's actually reactivate this breakpoint and run. Okay, so is binary is false. If we take a look at the log down here, we are currently loading the vertex shader source. Okay, so file size is 4927. We are going to increase that by 1. Right, okay, so that is good. Read size is 4927. So, interestingly, we want read size to be, less than or equal to file size. Okay, that makes sense. Ecliptic Fate, Ecliptic Fate. Thank you for the posture check. I appreciate that. My posture sometimes is terrible, so. The Hambone, thank you for the follow. Appreciate that. Let's see. Valiant Dev, first time chatter, welcome. We used C when we were studying it about 10 years back, but lately I've had to use C for Elixir native implemented functions. Came in full circle anyway. Nice. Let's see. Would also say you might want to build some stuff yourself, at least some toy projects, before trying to collaborate with others on stuff actually used by the public. That is a good point. I usually do bring that up, and I forgot to bring that up tonight, so thank you for bringing that up. Um, uh, basically, one of the things that I like to say, and I guess I kind of indirectly brought this up, was, by writing stuff and getting repetition in and practice in, write lots of little small things. But the other thing that I would like to mention along with that is don't get attached to your code. That's something that a lot of new developers do. They write something once and then they kind of get attached to that thing and try to reuse it and reuse it. No, throw it away and write it again. And the reason to do that is so that you get it more practice. You get more practice writing code, and eventually you'll be able to solve problems without having to look stuff up, right? Or very rarely will you have to look stuff up. If you do look stuff up, it'll be like looking at the Vulkan spec to see how something's supposed to act. But yes, definitely write, some smaller projects. Start with like text-based applications and then maybe move on to maybe like a simple Windows Forms application or something like that. And then move on to graphics programming, right? But make several of them before you try to contribute to something, as vast as something that uses Vulkan, because most things that use Vulkan are not tiny code bases, right? Prefer project-based learning. So I'm writing an API load testing tool in CPP to get the hang of it. That's fair. All right. You basically go from how do I do an if statement to what are the specs for this function and why is the result not exactly what I expected it to be, which is all the time with certain things in the C library. A good suggestion that somebody in chat made, I think it was somebody in the YouTube side made it. If you want to get a really good command of C, write a string processing library with all the functions that you would need to perform various string operations. Everything from like trimming a string to getting the mid of a string to parsing directories to parsing, even parsing something like JSON, right? Like, no, Sergeant Pepper, I would never say that. You're funny. But yeah, to get a really good command of C or even C++, write your own string library, right? Not using, if you're using C++, don't use std string, right? Write your own. Come up with it from scratch, something that handles all the allocation, all that stuff. That would be a really, really good project to actually work on to get familiar with the language. Let's see. Don't you have ads anymore? I have not been breaking for ads because we're kind of moving relatively quickly today. So I've not been breaking on ads, which is probably bad, but yeah, there should be. I think I have like auto ads on YouTube, on the YouTube side. But yeah, Twitch normally gets them every half an hour. Finishing 0.8 today. I am trying to. I don't know that we're going to hit that today, but we're just working through a list of bugs, essentially. Okay, so if read size is not equal to file size, then we have a mismatch, which is what we expected. We do want to, let's see. Oh, we allocate. This is why it's failing right here. So we're using the read size. Okay, I think I had this previously set to only do this if the read size was greater than the file size, I think. So essentially what this does is it says if for some reason we read more bytes than what the file said that we had, then we actually create a bigger array and copy over the memory from the read size from the data to temp and then free. That's still kind of not right, but that might be part of the problem. let's try that. All right, so we are going to allocate 4928 bytes of memory. And then if we take a look at data and we, let's see, we look at 4927, we have 0 terminated string, which is perfect. If we look outside of that, right, we'll obviously have rubbish. But this means at least that our string is being terminated correctly. So that aspect of it is working. And then if read size is greater than file size, which it is not, we're not going to resize that. And then obviously we output the file size for the out size. So I think maybe that may have done it. Let's go ahead and do that. Okay, so let's see what all these other errors are. Yes, that solved it. That is what the actual solution is to the actual problem. So we can see here that both of our shader stages compiled successfully. All right, so we got through that. That's good. Let me go here, and I'm just going to remove this because we don't need that. And do we have any other debug code in here? I don't think so. Let's just go ahead and say account for the null terminator for text files. Okay. All right. I guess this technically is, I don't see a situation where, wait a minute. Oh, this means the data is technically bigger than it needs to be, and that a smaller block of memory can be used. Okay, so if the read size is less than the file size, but we can't just, we should probably fix this function too so that it works correctly. Okay, so this technically worked because these were inverted, right? But if our file size has been ballooned by 1 because it's binary, I feel like we should split this into 2 variables, right? Like maybe we have original file size, right? We output to that. And then what we have here is we have another U64 actual file size, right? And this is going to be equal to original file size. And then actual file size gets incremented there. And then we want to use the actual file size here. And we want to use the actual file size here. And then for this one, we want to use the original file size when we're doing this comparison, right? And then if we are doing a copy, we'll use the read size, which does make sense. And then we'll free the, well, I guess this was made off of the actual file size. And then we'll say actual file size is equal to read size, and then we do actual file size here. So we only really need to use, we only really need to use the original file size, right? Here for this initial comparison, because we might have stepped it up here. So that should make that block work like intended. Let's go ahead and restart this just to make sure we didn't break it. I don't think that we would have. Okay, so we still have our Vulkan issues, so we'll have to step and do that, but we're still good. Okay, so VK push constant range size. So we're getting a 0 size on push constant ranges. So let's take this and we're going to do a search. And there are 2 places where we have push constant ranges. Let's see. But only one of which where we actually determine the size, right? So if we do not use push constant ranges whatsoever, then that is 0, and obviously the range count is 0. If we have ranges, then we are going to use those. So this is the block that we're going to be interested in, and I'm going to put a breakpoint there and restart. And we should hit that before we actually hit any errors. Yep. Okay, so if we take a look at our ranges, which is, in our case, let's see, we have push constant range count, so we only have 1, so we only need to be concerned with the first one. We have stage flag 17, offset and size are 0. Okay, so our config push constant ranges, first is 0 and 0. So why is that? So this is created here. And we have our per draw info UBO stride is what was used for that. So I'm going to put a breakpoint here and restart. And I'll bet that's 0 as well. In fact, I can almost guarantee it's going to be. Yes. Okay, so what shader is this that we are currently looking at? So this is render shader create. So this is our internal resources, and so I can actually do shader resource and base name. Okay, so we can actually do debug console. So we can actually do this. So shader resource, I think we need base.name, right? And that is shader material standard. That's kind of what I thought it was going to be. So we are creating our pipelines, and for some reason, our UBO stride is 0. So let's take a look at the actual material standard shader configuration. So this is the file that essentially drives, let's see, make sure you guys can see this. Yeah, you can. Okay. This is what essentially drives that, right? So we have our stages here, vertex fragment, our attribute configuration with each of our attributes and its type. And then we have all of our uniforms here, right? And the one we're interested, we have per frame, per group, and per draw. And the one we're interested in is this per draw. Now, this is of type struct, and its size is 84. Now, that being said, we have a note up here. This file is actually no longer required. We are actually generating the equivalent of this file in code so that we have things like this data here that we need. So I should probably put like some stupid invalid values for some of this stuff so that we know if we ever accidentally load the file, right? And we're eventually going to nuke this file. But essentially we're generating a copy of this in code. So if I come to the material system, we have in here our material system initialize, and one of the things that we do is we set up the standard material shader. And so what we do is we essentially create a asset in code, and then we set up all the attributes for that stuff, come down here, we serialize that to a string, which essentially generates this, and then we pass that off to the shader system and say, hey, load this shader system, but use this source that we provide as your configuration instead of trying to load it from an asset. The reason that we do that is because we have various properties that we can declare in code that we would only know in code. So we have things such as the number of groups or the max instances or the size of these structures, right? Here we have these sort of hard-coded values in here, but anytime that changes in code, we'd have to come in here and sync that up, and that sucks. So instead of doing that, what we do is we can simply come in here and create our individual uniforms, and for the size we can do just a size of that actual struct, and then we know the actual size of the actual data that we're going to be passing through. And so that and between that and getting counters for like array sizes and things like that, it just makes things a lot easier to deal with. Okay, so the interesting bit here is this is all basically generated off of the size of a uniform data struct. So if we take a look at this, this has exactly what appears in the actual shader itself. So just to show you guys what we mean, we have material standard. Let's just go to the vertex shader, that's fine. And if we come down here to our push constant, right? Our per draw UBO, which is called material draw UBO. If you look at these properties here and you look at these properties over here, they line up exactly, and that is not by accident. So essentially, we make sure that the structure here matches the structure here, and then we never have layout or alignment issues because exactly what we're passing in from the C side to the GPU side matches. Okay. So, where was I going with that? Okay, so in the material system itself, we're generating our shader configuration. So I suspect somewhere along the way, where we're doing this, it is not getting translated to the actual asset, right? And or resource. So I'm going to go into K resource handler shader, and I'm going to take a look again at asset to resource. So this is essentially what takes the asset that is read from disk, or in this case, read from a string source that we pass. And then this actually translates that into a resource shader, which is ultimately used by the shader system. So our uniforms is specifically what we're going to want. And anytime we have a struct, then we have the config size. Let's see. So do we have the uniform count, but do we have, I don't think, let's see. Actually, the issue might not actually be here. The issue might actually be in the shader system. Maybe the shader system isn't taking note of this. So when we do shader create, we're passing through that resource that's been grabbed. So let's take a look at that. Let's see. We want so we process the uniforms. Here we grab sampler indices and texture indices. I think that I think is fine. What I want is where we are looking for the size, and I actually don't see that anywhere in here. So we have we process the uniforms twice, which we might not actually need to do. Well, yeah, I guess we do have to do it. So we need to get counts of how many uniform samplers we have and how many uniform textures we have. And then we use those to allocate these arrays, and then we go ahead and set them up after that. So I think the issue might be in here. So we have internal uniform add, and I believe this is where the size should be taken into account. Let's see. Thank you for the subscription over there on the YouTube side. I appreciate that. Welcome. All right, so internal uniform add. So we add to the shader a uniform config at a specific location. So this should be, let's see. Here we go. So if the frequency is per draw, the entry size and offset are taken into account. Otherwise, wait a minute. Oh, interesting. So per draw UBO size is only taken into account here, but I don't see where we're actually incrementing that. Oh, it's here. Okay. So here's where we look at the update frequency to figure out what frequency it falls under, whether it's per frame, per group, or per draw. And it looks like these are set up correctly. Entry size, which would have been set up here, times array length. So I'll bet this is what's clobbering it. I'll bet array length is 0. So what this actually should be, let's go to here. And this is new logic, so I'm thinking what this actually should be. So entry array length, right? If that exists, entry array length. Otherwise, if it doesn't, we're going to use 1. And the reason why we're going to do that is because if that is 0, then we want to actually use 1 for there when we're calculating the size. Why? Because obviously multiplying by 0 gives us 0, which is not going to be what we want. I suspect this is where that bug resides. This is kind of repetitious too. You know what? I'm actually really not a fan of the way that this is done. So I think what I'm going to do is... What the heck was that? I think my dog just went bananas in the background or something. Okay. Anyway, so what we're going to do is we're going to take a pointer to the shader frequency data, and then we're just going to update that in one shot. So we're going to say shader frequency data. We'll call it frequency, maybe? Do we have anything in here called that? No. And then we're going to default it to this, and we're going to say frequency equals the address of shader per frame. And then we're going to do the same thing down here and the same thing here, but we're going to change those to per group and per draw. And that's so that we don't have the same code repeated, because that sucks. We're going to do frequency, UBO size, frequency, uniform count. All right, and that's if, we're going to say if not frequency, then no frequency found. Investigate this, right? That's actually going to be a fatal issue. Because that means that we've added like a frequency or something that we can't truly handle. Or one that hasn't been accounted for, which would be terrible. Okay, so that should solve that. So let's go ahead and run this again. All right. So UBO stride, still 0. So interestingly, we do have a sampler indices array and a texture indices array. It looks like, I mean, I guess those are filled out, right? Why is this UBO stride 0 still? It definitely should not be. So I guess what we're going to have to do is I guess we're going to have to debug this, right? In fact, I think I'm just going to skip straight to per draw because that seems to be the issue. All right, so frequency is per draw. And then we have the UBO size here. So we have entry size, which is 96. That seems correct. Okay. So array length is 0. So, okay, so this is 0, right? So that definitely would have been an issue. So we're going to change that to 1. And then we should have our UBO size set there. So at this point, that is working correctly. So that was an issue that we found. Let's see. So the per draw state UBO size is 96 here. So we did find that, right? We have one uniform count. Okay, so at this point, when we're loading it in, this is correct. And then here we're just counting up like indices and things like that of textures and samplers. So if we go ahead and take a look at this one more time, so we can see we have no sampler indices or texture indices for per draw, but we do have one uniform that is 96 bytes. If we take a look at per group, we have one texture and one sampler and one uniform that is, one uniform, which is a struct that is 656 bytes. And then per frame also has that much, right? 688. We do have 2 samplers and 2 textures. So I'm pretty convinced that that is working correctly, especially if we take a look at our configuration over here. We can see that per frame has a single UBO object in here, right? And then we have 2 textures, 2 samplers. If we look at our per group, we have 1 texture and 1 sampler. Technically, these are arrays, right? And then we have the material group UBO struct there. And then for per draw, we only have a struct. So I guess we could also take a quick second and just take a look at these guys. Sampler indices 6. Okay. So yeah, I think we are, I think we're looking pretty good here. Let's see. So we have, okay. Yeah, I think we're doing pretty well here as far as this end is concerned. Now, we are going to pass the shader resource across to render shader create. Now, the interesting part of this is the shader resource. Does the shader resource actually contain everything that we need it to? I don't think it does. So we have stage configs. Thank you for the follows, by the way. I appreciate that. Welcome. Let's see. So we do see we're getting our max groups, our max draw count, uniforms. So I think we do have to reevaluate this, I want to say, on the shader create side. So let's go into the back end here. Validate this. I do believe we have something that steps through there's a set of this data internally too. We're processing the uniform. Oh, wait a minute though. We don't have to necessarily do it this way. We could probably simplify this quite a bit, in fact. And I also see, so here's where we're cycling through the uniforms. We load the uniform config that comes from the shader resource, right? We go ahead and grab the correct info, texture indices, uniform size. Okay, we're making the same mistake here. That's part of the problem. Okay, so let's go to we are making the same mistake here, right? Because the config array length for these is going to be 0 for non-arrays, right? So what we really need to do is whoops. We need to say uconfig array length if it exists, otherwise 1, right? And I'll just wrap this whole thing up. So we're making the same mistake there that we did on the front end. And the reason that we have that same logic in both places is because we need to know about that same information in both places, but the only connection between the renderer front end and the renderer back end is via a handle. So we're not passing pointers back and forth between those two. We only have the resource to look at. So that is why we do not have that synchronized between front and back. Thank you for the follow. Appreciate that. All right, so let's go ahead and run this. I'm going to kill this breakpoint because we know that's working. And I'm going to go ahead and I'm going to kill this one too. And our UBO stride is still 0. Did we not? Oh, we didn't. Let's see. Uniform size. Uniform size is we're not. Yeah, we are. We are incrementing it. Internal shader uniforms sub I. And we're setting the uniform size. So I guess I'm going to have to step through this. I was trying to avoid doing that, but here we are. Okay, so array length is 0, so as I suspected, that was going to be an issue. The config size is 688. Okay, so we do have uniform size, so that's going to be our per frame one, right? So our uniform count is 1 now. Okay, we're going to copy over all the size, frequency, all that good stuff. So let's take a look at this uniform. So we have array length 0. We do have the size of 688. Okay, so info UBO size, which the info in this case is the let's see, the per draw info. Or no, I guess we're on per frame right now. I think. Yes, per frame. Okay. So, so we go ahead and add that to per frame. Right. And then the next one is going to be a texture. So we increment that, add it. The next one is going to be a sampler, I think, or actually another texture, and then 2 samplers. Yep, 2 samplers. Okay, and then we're going to skip to the next scope, which is going to be per group. So we're going to have an array of textures and an array of samplers. Right, so there's texture, and then array length, is 0. Interesting. So the array size did not get picked up on that. Well, that's no bueno. So we're going to have to fix that. Let's see. So this is going to be the sampler. Okay, and then we should have this structure, right? Which is, yep, okay, that makes sense. That lines up with this. Okay, and then per draw is just going to have this one, right? So that's going to wind up being 96 in this case. This is out of date because we've added more stuff to it, right? So it is not an array, so we use 1 times the size. That is the uniform size. Okay. So uniform size is there. So UBO size should be per draw info. UBO size is 96. Oh, wait a minute. Are we looking at the stride, not the size? I don't think we actually set the stride. I don't think we set the stride. I'm pretty sure that's actually what the problem is. Okay, so let's just skip past this. I'm pretty sure, yep, we didn't set the stride. I've been thinking the size this whole time. And what we really need is a stride. I mean, we need the size to get the stride. Okay. So the difference between the size and the stride, and I know this is a little misleading because we actually have size here for the push constant. And this is going to be true for the uniform buffer as well as our push constants. This is going to be an issue in both areas. So when we talk about the UBO size versus the stride versus the offset is where it is in the buffer, right? So for our per frame UBO, that's how far it is in the per frame UBO, right? Or the uniform buffer rather for per frame. Same goes for group, right? But per draw, that's a push constant, so that's always going to be 0 for per draw, so that makes sense. The size is basically how big all of the uniforms within that UBO are. Now, we are loading everything as a struct here, so it's all one thing that is, 96 bytes, right? The stride is basically how much space we have in between units of that. And so the thing to consider here is that this is handled a little bit differently between your standard uniform buffers and push constants. So generally speaking, your GPU has a minimum alignment that you have to stick to, a minimum memory alignment that you have to stick to when it comes to UBO offsets. And so generally speaking, I think for a lot of cards, that's like 32 byte alignment or 16 byte alignment. but on some NVIDIA cards that can be as high as 256 byte alignment. And so what we do is we can actually query what that alignment needs to be, and then take the UBO size and say, hey, make sure that the stride of this is aligned, or is essentially the aligned to that amount. So what that's going to do is it's basically going to say, okay, we really only need 96 bytes, but in the example of the NVIDIA cards that require 256, our stride would actually be 256. And so we'd only wind up using, that first part of memory, but because the NVIDIA card requires that 256 byte alignment, the next portion that we can have, or the next offset for the next UBO within that buffer, has to start at 256 and then 512 and so forth. And so that is what we use the stride for, is to figure out, we have the UBO size, but then the stride is how much space is in between actual instances of that within the uniform buffer. And so there's a different requirement for that for standard uniform buffers, and then there's a different requirement for push constants. And the Vulkan spec only guarantees 128 bytes of push constant space, and we only ever use one range. So we go ahead and we align to 128 for Vulkan specifically within that. So what we really should be doing is when we are setting up our push constant range, we're technically going off of the UBO stride, right? Which is the right thing to do. But we really should be setting that up where we're setting up all the other stuff for UBOs. So when we are, let's see, let's go back here, right? Actually, I think we already had it here. Okay, so this is in the Vulkan backend, right? Once we processed all the uniforms, what we're going to do is we're going to say, let's do, where was that? We wanted internal shader per draw info. And then we're going to say UBO stride equals 128. Okay. We're going to put a note here. Vulkan, I guess we can say the Vulkan spec only guarantees 128 bytes of data. Therefore, we align the UBO, aka push constant stride to that, and only ever use one, right? So that is going to eliminate that, and we would also get the same thing if we were to do, which is technically the more correct thing to do. Let's see, that was in defines, I think. It might have been memory. Get aligned range is what we want, right? So we do an offset, a size, or actually I think it was get aligned, where we provide an operand and the granularity, right? So what that does is, so we say get aligned, operand is going to be the internal shader per draw info, and the granularity is going to be 128, right? So this is, draw info, UBO size, right? So this is technically going to give us essentially a multiple of 128. And so that should give us what we need for that. We're also going to have to do that for the other scopes as well. So the other frequencies, rather, can use the UBO min offset from the data or the device limits. Right? So we can take this same thing, and I'm going to paste it twice, and we're going to do per frame info and per group info. Whoops, underscore. Okay, and this is going to be, let's see. Whoops. Let's see. So this is going to be group, and this is going to be frame. Actually, no, we don't want to use that for this. My bad. Delete this. We're going to do context, device. Let me think, what was it? Wasn't features, properties, limits, uniform buffer, min uniform buffer offset alignment. That's it right there. That's the property that we want to use, right? And so actually we want to take, oh, wait a minute. I was actually right about that. This is what I want to use. And we want to essentially align to this minimum buffer offset alignment, right? So we want, oops, that's got to be per frame. Okay. And so we want to take this and do the same thing there, right? And so this, we're actually querying the actual device's requirements. And so we can align accordingly with what the device actually requires. So if your device requires, 16-byte alignment, it can use that. Or if you have one that requires 256-byte alignment, it can use that. Okay. So that should fix that. I'm sure there's other issues that we've got to sort out as well. Okay, looks like we hit a breakpoint, that's why. Okay, kill that. And we should have push constant range of 128 now. So that is what we actually expect. So we can go ahead and kill that breakpoint. And now, setup frequency states. Okay, so we have a segfault. Is out frequency ID defined? I don't think that it is. I suspect not. It is not. Okay, so let's figure out what is trying to request that. Oh, there it is right there. We passed a 0 to it. Why did we do that? Why did we pass a 0 to that? Let's see. So let's take a look at that's definitely wrong. Okay, so shader creates setup frequency states per frame. This out frequency ID. I know why we passed 0 there. That's not incorrect. So we don't actually need a frequency ID for per frame. What we really need to do is out frequency ID. Okay. Oh, this is backwards, I think. Yes, this is backwards. This should be equal. Right? So if we're doing per frame frequency, we just want to get this. We only want to generate a frequency ID if we are not doing that. That's the problem. Inverted case. All right, so let's see how much further we get. Okay, so we are a little bit further along, I think. Are we? Yeah. Well, we've got a whole bunch of other stuff that we have to figure out, though. I feel like this is all fallout from stuff not being set correctly, though. So we know there's some issues around that. So what I am going to do, we are out of time for tonight. It is just past 11 here, my time, and I do have to get up early for work. So this is where I'm going to wind up ending the stream for tonight. Let me go ahead and get this all checked in, because at least we are compiling and we are crushing bugs one by one. So we're going to do that, get status. So this is all the stuff we modified tonight, plus some of the stuff I did offline. Commit. So everything builds. Actually, I already did that. So actually, this is stuff we've done tonight. So various refactor bug fixes. Stream work. Okay, and we'll push that. All right. And so that is available if you guys wanted to take a look at it. It is available on the featured K-Package branch. We didn't get through it tonight. That's just the way it goes sometimes. We spent a little bit longer on some things than I really wanted to. But at least we were able to dig in and really figure out why it was doing what it was doing. So with that said, normally we do schedule another stream on Thursday, which would be tomorrow. However, I am going to be attending something that was previously scheduled and will not be available to stream tomorrow. So we are going to pick this up more than likely on the next regularly scheduled stream, which will be next Wednesday, which I know is kind of a long time. I don't think I'm going to be able to make it up this weekend, but if I do, I'll be announcing that on X and or the YouTube channel and the Discord server if you're not on there. So thank you guys for the follows. If you haven't already followed me, I would really appreciate the follows. Let's see. Let me just catch up with a couple of chat things here real quick. What's on the shelves? Stuff looks cool. Yeah, I have a lot of stuff on here. I should probably do like a I can't really move my camera, right? But I've got all kinds of stuff up there. Including like a little Mario box that like lights up, you know. All kinds of figures, and then I've got a let's see if you can see it there. I've got a I can actually make this a little bit bigger. Let me go to this one. Yeah, so I've got right there. I've got a like a black mage, and I've got a whole bunch of games up there. And I've got actually a bunch of figurines in here, which is actually behind this light. That's terribly positioned, so I should move that so you guys can see it. I don't know that that's much better, but yeah, at some point I'll have to, you know, kind of zoom in and or find a way to show you guys that stuff. But yeah, I've got all kinds of cool stuff up here as my backdrop. All right. Anyway. OG WoW boxes, yeah, exactly. Yeah, I have those up there. Yep, the original ones for sure. So, yeah, we are done for tonight. I'm gonna find somebody to raid, and let me see. I'm just gonna see if I can find something quickly that is loosely related. All right. Let's go ahead and let's. I'm looking for something that's kind of related to what we're doing, but. All right, let's go ahead and raid. Wait a minute. Was that? I'm going to go ahead and raid Jitspo. We haven't raided him in a little bit. So he's making a pretty cool retro-looking FPS in Godot, and it's really neat. And he's got some pretty cool mechanics that he's building into that. He's also written like a custom BSP importer and all kinds of really neat stuff. So we're going to go ahead and read him. And thank you guys for joining me. I really appreciate it. Appreciate you guys hanging out. And yeah, we will catch you guys on the next stream. See ya.